All right, guys, we're going to add to our last set of new notes for the year. So we have our three-dimensional shapes table of contents right here. And starting on page 118, let's see, what's the best way to number this? I think we're going to go 118 to 119. 118 is sort of the intro page for kind of both 119 and 120. So let's put 120 right there, but we're just going to do this one for today, and we're going to talk about the surface area of prisms. Okay. So, like we talked about yesterday, a prism is a shape with two bases. So two parallel and congruent base shapes. And that's kind of how we name the prism. So, for example, if I have two rectangular bases, then I call it a rectangular prism. If I have two square bases, I could either call it a square prism, or sometimes we call that a cube. Like, just think of a die. That's a cube. If my two bases are triangles, then I have a triangular prism. Or hexagons, so a hexagonal prism, or a trapezoid, or whatever. You get the idea. Trapezoidal prism. That's fun to say, trapezoidal. So that's kind of how I determine that I have prisms. Now, I will tell you, when you're dealing with something that is rectangular or square, it can be tricky to sort of identify what your bases are, because maybe you weren't thinking it was side to side here. Maybe you were thinking it was top to bottom. And kind of with rectangular prisms and cubes, it doesn't matter so much. But when we have like other shaped prisms, like triangular, hexagonal, trapezoidal, those are more important. You do need to pick the two kind of weirdly shaped prisms is sort of the best way to describe it, because the thing is, the stuff that wraps around those bases, if you sort of unwrap it and unfold it like we were looking at with our nets, that whole like wraparound portion really unwraps to be this long rectangular piece. So like each of these strips coming down is a rectangle. Like if you think about this flat edge on our triangular prism right there, each flat edge is its own rectangle. And that's why the rectangular ones and the cubes can be tricky. So as long as you pick two to be consistent with, like the parallel two, you will still be able to find surface area and lateral area correctly. So, like we talked about, surface area of the entire shape is like all the paper that comes apart when we like cut it and lay flat our net. So to find the surface area, we end up with the area of two base shapes. So like finding the area of the trapezoid and doubling it, because I have two of those, plus the area of all the stuff around, so which is a rectangle, so kind of base times height, which the height is like how high it is from trapezoid to trapezoid or triangle to triangle. And then the base, what really happens with the base of that rectangle is it's all the stuff around. So that is the perimeter of the base shape times the height. Sometimes all we want of the area of a three-dimensional shape is the stuff around, and that's called lateral area. And so if I only want the stuff around, then I only want perimeter times height. I don't want the area of the bases. And then we'll fill out this last one a different day. So on to the next page. Alrighty, so sorry this got a little bit chopped off, but this says lateral area. So lateral area is the area of all the rectangles around. So if I think about my two bases, all the stuff around those bases falls apart into a rectangle. So we're finding the area of all the rectangles around. Essentially, it's not base area. It's all the other stuff. And so when we're finding lateral area, we use that formula, perimeter times height, where again, perimeter is perimeter of the base shape. And then H is height of the prism, so from base to base. B to B. Okay? It's very specific how we get height. It also needs to be perpendicular, just like it was when we were doing flat area, two-dimensional area. Now, if I do want the full surface area, then that is the area of the bases and the stuff around. So area of two bases and lateral area, so stuff around. And so our formula for that again was 2b plus pH, where pH is just this one, so we already know it's perimeter of the base shape times the height of the prism, base to base. But big B stands for area of base shape. So this is just a lot of finding area. I mean, honestly, like if you like the last chapter, we're just going to do way more of it. So for instance, on this rectangular prism right here, whenever we have rectangular or square prisms, like I said before, it's kind of harder to figure out what is our base shape. And also it kind of doesn't matter. So you pick a base. Let's say I go with the bottom because that just feels right and makes sense. Okay. Oop, dang it. So if I pick the bottom as the base, then sort of everything else works itself out. So if I want to find the lateral area, we're going to do P times H, where again, P is the perimeter of the base. So let's try to do a little color coding here. We're going to do perimeter of the base. So if I want to do perimeter of the base, I'm going to do 10 plus 3 plus 10 plus 3. Or, 10 plus 3 and then doubled. So kind of 2 10 plus 3s. And then the height of the prism needs to be the height from base to base. So since I picked the bottom as my base, the top has to be the other one. And so the height from here to here is 5. So we're going to also multiply this by 5. Okay, so if we simplify this a little bit now, I would do what's in parentheses for 13, and then we're just multiplying all these numbers here. So I would probably multiply and get a 10, and then times 13 for 130 units squared. Okay, now if we already know the lateral area of the shape, then finding the surface area is a little bit easier because our surface area formula is 2 times the area of the base plus perimeter times height, and I already know that number. It was 130, so we can just plug that in. So what we need to do is do 2 times the area of the base, and the base shape that I picked was, again, that pink bottom shape, which is a rectangle. And we find the area of that by doing base times height, so 10 times 3. And then we just want to follow order of operations, so I'd have 30 times 2, so 60, plus 130 for 190 units squared. So it's just a lot more area. Let's try a few more. Okay, so looking in here, this shape, if I want to find the lateral and surface area, I have to pick the correct base because this has a very unique base. It's a circle. So unlike the one on the front where I could kind of pick whatever base I wanted, didn't have to be the bottom, could have been a side. Here I have to pick the circle as the base because the circles are unique. The stuff around is a rectangle. I can't pick that. So for lateral area, we're going to do perimeter of the base times height. So perimeter of the base is perimeter of a circle. And perimeter of a circle is actually called something special. It's called circumference. And that's 2 pi r. So we need that radius, which is unfortunately not 3. It's the diameter. Although 2 times, gosh darn it, I already wrote that 2 down. 2 times the radius is the diameter. So we can just use the 3 for diameter. Because like circumference is also d pi. Then for height, we want the height of the prism. So height from base to base. So this time from circle to circle, which is 5. So all in all, my lateral area here is 15 pi. Which again is super nice to have because if I want to find the surface area, we're going to do 2 times the area of the base plus the lateral area, or perimeter of the base times height, which I already have. So 15 pi goes there. And then if we think about our base shape, my base shape is a circle. And to find the area of the circle, we need to do pi r squared. So unfortunately with this one, I do need to get the radius, which is going to be half of 3, which is 1.5. I'm not going to do it. I'm going to keep it 3 over 2. Really drive you guys bonkers. And then we got plus 15 pi at the end. Because when I square a fraction, to me in my brain, it just works out better because I'm just going to square a 3 and a 2 rather than a decimal. So we will have, oh my gosh, I'm going to kind of run out of room here, 2 times 9 over 4 pi plus 15 pi. And then I can reduce a little bit here because the 2 and 4 can divide into each other with a 2 left on the bottom. And so what I have here is 9 over 2 pi plus 15 pi. And I can add those because they're both pi's, but I also can't add those because they don't have the same denominator. But I can kind of think of this 15 as like a low-key 30 over 2. Because 30 over 2 is 15. And 30 over 2 has the same denominator as 9 over 2. So now I can add them for 39 over 2 pi units squared. Oop, I forgot my units squared up here on lateral area. So there you go. If we wanted the exact, we have that. But if we wanted the approximate area, we'd have to multiply by pi. So. All right, moving over here. I have to pick a very specific base on this one. If you look at it, there are 1, 2, 3 rectangles and 2 triangles. So 2 bases. So the triangles are the base shape. It's not like you just get to pick the bottom. You have to pick the one that there are 2 of. So if I want to find the lateral area, we're going to do perimeter of the base times the height of the prism. So perimeter of the base, I need to add up all the sides, and I kind of don't know them all right now. Like they've shown me that this side here is 3, this side here is 4, and that side I do not know. But it's on a right triangle, so I could do the Pythagorean theorem to figure it out. So 3 squared plus 4 squared equals, I don't know, squared. And better yet, if you are remembering your triples and kind of the most used triple, 3, 4, 5, you already know that this hypotenuse here has a length of 5. So just finish that out real quick. If I want to find the perimeter, we're going to add up all those sides. So 3, 4, and 5. The height has to be the height from base to base, so triangle to triangle. So I can see that they're showing that right here with a 5. And they would all be the same all the way around, but like we're just going to write it once. So, all right, so to find that lateral area, the area of the stuff around, we're going to add up on the inside here for 12 times 5, so 60 units squared. And then when I want to go find surface area, I have it half done already because we're going to do 2 times the area of the base plus the lateral area, which was 60. And so then when I think about doing 2 times the area of the base is a triangle. And how do you find the area of that? Well, we talked about last chapter, the area is half base times height for a triangle. And so right now I can already simplify a little bit because 2 times half will just sort of go away because that's 1. And then base and height of the base shape of the triangle has to be the base and height between a 90, so the 3 and the 4 for 12 plus 60 is a surface area of 72 units squared. There you go. Alrighty, moving on. Looking at this one right here, I can see rectangles all around, but only 2 pentagons. So the pentagon has to be my base shape. So if we want to find the lateral area, we're going to do perimeter times height. So perimeter of the base times the height from pentagon to pentagon, or height of the prism. So the perimeter of the base here, we have to assume that all of our shapes are regular. Otherwise, we can't really do this. So assuming that this pentagon is regular, to find the perimeter, one side length is 4, and there are 5 of them. And then the height from base to base, or pentagon to pentagon, they're showing you right here, is 9. So we're going to have 20 times 9 for 180 units squared. Now, unfortunately, that was the easy part. Because now when I want to go find surface area, I'm going to have to do 2 times the area of the base plus that lateral area, the perimeter times height, which I already know is 180. The tricky thing now is finding the area of the base shape. When my base shape is a pentagon, I have to do half apothem times perimeter. Now, kind of like with the triangle one, the 2.5 can sort of go away, and so really I end up with just apothem times perimeter. Now, I will say the one nice thing is I already know that perimeter because this is perimeter of the base, and literally just did that here. It's 20. The trouble is I don't know the apothem, and they have not labeled it for me. So if I think about drawing this apothem in and creating my little baby right triangle, you thought we were done with those. What I know on my little baby right triangle is that the half side is 2. And then if I only know one or the other because I don't know the apothem, I have to find my central angle. So I have to do 360 divided by 5 because there are 5 sides, and then divide that by 2 again, which I need to get my calculator. Well, that's really just divide by 10, so 36. Oh yeah, 72. Got it. So my top angle here is 36 degrees, which is not a special right triangle, so I have to use trig. So I have to have my calculator. A moment, please. Don't know where I put my calculator. Oh my gosh, I have to get up to get it. Sorry. All right, here we go. So if I want to find the apothem, I need to do some trig. And whenever I only have to find one or the other, we always use tangent. So we're doing tangent of 36 equals the opposite, which is 2, over the adjacent, which is the apothem, which I don't know. So we're doing a little swap-a-roo to get that apothem by itself. And then we're going to type this into our calculator. So 2 divided by 36 tangent equals, and so this is my apothem, which I can put right here, but like the less I round, the better. So I'm going to actually multiply that by 20 right now. And then I'm going to have to add the 180. Again, to get my least rounded answer, so plus 180. And so we get 235.06 units squared if we round to the nearest hundredth. You thought we were done with apothems. Never. Okay, last one. So on this last one, I noticed that we have 2 trapezoids. So the trapezoids have to be my bases. We're going to find the lateral area first. We're going to do perimeter of the base times the height. So when I look at this trapezoid at the front, I can see that one side is 3.5 and the other side is 4, but then they didn't label this one or that one. But they did label them back here, and the parallel bases are congruent. So when I'm finding this perimeter, I kind of have to look at both bases to get all the sides. This left side here is 3.5. The bottom is 4. This side is 3.5. And then the top is 3. Then when we're talking about height, we're talking about height from base to base, which doesn't always mean up and down, right? If I need to go from trapezoid to trapezoid, I'm actually going front to back. And so if I travel from the front to the back, the only place they show me that is right here. So the 6. Oh, geez. Sorry. Okay, so I do have to do what's in parentheses first, and I'm going to add up those decimals so that I no longer have them for 7, plus another 7, so 14, times 6 is going to be 84 units squared for our lateral area. And then when we're thinking about finding that surface area, we're going to do 2 times the area of the base plus the lateral area, which we just found was 84. And then when I think about finding the area of the base shape is a trapezoid, so I do the formula for that, which is half height times the sum of the 2 bases, which have to be the parallel parts of the trapezoid. So again, just like the last 2, because I have 2 times half right here, that can kind of just go away for a 1. And now when I'm looking at just the trapezoid, I need the sum of the 2 bases, the parallel ones. So that's a 4, and that's the top, which was a 3. So we got 4 and 3 in there for our bases. And then I need the height of the trapezoid. So not the height of the prism, the height of the trapezoid, which goes from base to base or parallel to parallel, which I can't see here. So then I always go check my other one, and they are showing me that here. So this 3 is the height of the trapezoid. So that's why I like finding surface area can sometimes be confusing, because you're finding lots of different heights and lots of different bases. So you really have to keep it straight. Am I finding the area, or like, am I finding the height of the base or the height of the prism? And those things are different. So we're going to get 7 times 3 for 21 plus 84 for a total area of 105 units squared. All right, I'll see you in the next one.